All right, so our exponential equation, y equals a times b to the x power. Okay, again, most of this is going to be review to start out. So the a value, this is our initial amount, the starting amount, okay? Initial population, starting population, that kind of thing. Now, the y value is the ending amount, okay? What we end with, the ending population at so many years, okay? Starting amount, ending amount. The b is our growth or decay rate, or growth factor, decay factor, okay? What we're multiplying by, the pattern. And then x is going to be referred to as time now in word problems. It could be weeks, could be years, could be days, but it's some amount of time. All right, so let's review. This is from 8.1. Okay, we've talked about this before. All right, number one, given the exponential function y equals 150 times 1.03 to the x power, what's the initial amount? 150. B, what's the growth factor? Good, 1.03. And then the percent of increase. Okay, good. So to find the percent of increase, since we're talking about percent, we can set that growth factor 1.03 equal to 1 plus r. Okay, and then solve it for r. So subtract 1. So 0.03 equals r. And then move the decimal 2 places to the right to convert from percent or decimal to percent. So this would be 3% increase. But we're multiplying, the pattern is multiplied by 1.03. Okay. All right, number two, given the exponential function y equals 75 times 0.15 to the x power, what's the initial amount? 75. B, what's the decay factor? Okay, 0.15. And the percent of decrease? Okay, good. So this is a question that was on the quiz. Okay, this is the question that I told you to star on your notes and said, a lot of people are going to miss this, and I was right. All right, so we set 0.15 equal to 1 minus r. Right, because this is a decay, decreasing. All right, so then when we subtract 1 over, we get negative 0.85 equals negative r, and divide by negative 1. So r equals 0.85, and then move the decimal 2 places, so 85%. All right, so it's decreasing at a rate of 85%, but the pattern is to multiply by 0.15. Okay, a lot of people on the test or on the quiz yesterday, if this was the problem, they put 15%. They just moved the decimal 2 places. You have to subtract 1 off there. Okay. All right, number three, Vince bought a car for $15,000. The value is expected to depreciate. That's decay, decrease, okay? 6% a year. Write an equation that models this. All right, so our formula that we're starting with is y equals a times 1 minus r to the t power. Okay. Now we just plug the numbers in the right place. So we start with 15,000 times 1 minus r. R is going to be 0.06% as a decimal, 0.06 to the t power. Okay. Now, if you want to simplify that, you can inside the parentheses. That's fine. Or you can leave it like that if the question just says write the equation. All right, now B, find the value of the car after 3 years. So 3 years is time. All right, so that 3 is going to go in for t. All right, so 15,000 times, we could simplify this just because it's easier to put in the calculator. So we should get 12,458.76. All right, so it starts off at $15,000, and then after 3 years, it's worth a little over 12,000. All right, see, how long will it take for the car to be worth 8,000? All right, so now 8,000 is our ending amount. So that's going to be the y. So we're going to take our equation. Okay, basically this one right here. Now we have a value we can plug in here, and we're trying to find out how long it's going to take. So now we're going to solve for t. So we start with 8,000 equals 15,000 times, I'll just use 0.94 because it's just easier, to the t power. All right, so there's our formula. Now we're going to solve this for t. All right, so anytime your variable's in the exponent position, okay, you're going to do the exact same steps to solve this every single time. Okay. First step, always divide by this number. You have to divide this number over. Second step, change to a log. Like the log form. Okay. We did this before. Okay, that's why these word problems, really the hardest part now should just be plugging the numbers into the correct formula, because you should all know how to solve exponential equations. I never quizzed you yesterday. Right? So step 1, divide. Step 2, change to a log. Step 3, either you can throw it in the calculator the way it is if you have a subscript key on your calculator. If not, use the change of base formula. Rewrite it as the change of base, and then get the decimal. All right, so let's divide by 15,000. Now, if when you do the division on the left side, if the decimal stops, then give the decimal. It's just easier to input it in the calculator, that's all. If it doesn't, if it goes all the way across your screen, then you have to leave it as a fraction, just simplify the fraction. Okay. So this decimal goes all the way across, so you can't round in the middle of a problem. So we're just going to leave it as 8/15. So 8 over 15. If you don't like using the variable t, then use the variable x. All right, so now 0.94 is our base. That's our subscript when we change it to log form. So up here, so log, our base is 0.94 of 8/15 equals t. Right? So now we can use the change of base to rewrite this, so we can use the calculator. So log 8/15 divided by log 0.94. All right, and we just throw it in the calculator. All right, so you should get, we're going 3 decimal places, so 10.159. This is going to be years. So it takes a little bit longer than 10 years to go down from 15,000 to 8,000. All right, so now let's look at these last two formulas. These are compound interest problems. Anytime we're talking about money and finance, depositing money, investing money. So to use one of these two formulas, it has to have the word compound interest in the word problem. Okay? If it doesn't say compound interest, then you can only use one of these three. Okay? So you've got to make sure that you understand which formulas you can use. I mean, it's pretty, once you understand certain keywords, you're pretty much guaranteed which one to use. Okay? So if it doesn't say compound interest, you have to use one of these. If there's no percent even in the problem, you have to start with this one. If there's a percent in the problem that doesn't say compound interest anywhere, then you're using one of these two. If it says increasing, then you're using this one. If it's decreasing, then you're using this one. So it's pretty much guaranteed. Should be able to at least pick the correct one. All right. So compound interest uses two different ones. This one's used anytime there's a set number of compounds in a year. Okay, so I'll talk about what that means in a minute. All right, so what each of these letters represent is similar to these ones over here. It's just different letters, but they all mean the same thing. All right, so this number right here is our starting amount. It's called the principal, what we invest, what we start with. This is our ending amount. Okay, after so many years, this is how much money we have in the bank. Okay, starting amount, ending amount. All right, times 1 plus. R is the percent as a decimal, always as a decimal. Now, N is how many times it's compounded in a year. So that's how many times the bank is going to add money, interest, into the amount of money that you already invested. So if it says, so you're looking for a keyword after the word compound. So if it's compound annually, that means 1 time. So N is 1. If it says semi-annually, that means 2 times a year. So 2 times a year, the bank will add money into your account. Quarterly means 4. So 4 times a year, the bank will add money into your account. Monthly would be 12. Yearly means 1. Daily, 365. Okay, that kind of thing. So that's what that number represents. N, how many times it's compounded in a year. So it's down here being divided by, okay, and then it's up here as the exponent also, being multiplied to t. T is the number of years. Okay? So make sure whatever number you put down here, it has to go up here also as an exponent being multiplied to t. All right, now, in the word problem, if it says compound continuously, so this word has to be in the problem, okay, so if it says continuously, then this is the formula we're always going to use. T is our starting amount, A is our ending amount. E is going to stay E. We have an E button on our calculator. It's an E to the X button. Okay? So that's going to stay E. R is our percent as a decimal. T is number of years. Okay? So again, all these formulas are given on the test. You don't have to memorize them. You just have to know which one to use and how to use them. All right, so let's go ahead and turn this over so we can see how we can use these formulas. All right. So I'm going to just put the 2 formulas up here just so I don't have to keep going back and forth. All right, so number 6. What happened to 4? Here. All right. Okay. So number 4, the total of $14,000 invested in a savings account with an annual interest rate of 8%. Which of the compound options below would yield the best profit, so the most money? Given the money is going to stay in the account for 12 years, rounds in their cent, 2 decimal places. All right. So 14,000 is what we're starting with. That's our P value. 8%, okay, that's going to be R, but as a decimal. So R is going to be 0.08. The number of years they tell us is 12. That's our T, time. So option 1 says compounded annually. All right, since it says annually for option 1, option 2 is semi-annually, option 3 is quarterly. Each of these 3, option 1, 2, and 3, are going to use this formula right here. Option 4, compounded continuously. So that's the word that we're looking for. That's the only one that's using this formula. It's the only one you can use that says compounded continuously. All right, so option 1. Annually means N equals 1. Okay, so once a year, the bank will add money into the account. So now we just plug those numbers into the formula, and we're solving for A. So we're looking for the ending amount. So A equals 14,000 times 1 plus R, which is 0.08, divided by 1, raised to the 1 times 12. All right, so I just plug all the numbers in to the correct location. Now it's all calculated. Depends on how you want to use your calculator. Okay, you know your calculator hopefully better than I do. You can do PEMDAS on this. You can throw some of your calculators, you can just throw it all in the way you see it. If you want to practice using yours only for the test. Okay? So what I usually do is I do PEMDAS. I multiply these two numbers together, just turn it into a single number, we know that's 12. So then I work inside the parentheses first, and inside the parentheses I do the division, plus 1. Then I raise it to the 12, and then times 14,000. So practice putting it into your calculator. All right, so we should get, we're going 2 decimal places, so 35,254.38. All right, so we start with $14,000 at the end of 12 years. Should have a little bit over $35,000 left in the bank. All right, option 2, semi-annually. So that means n equals 2, semi-annually. All right, so again, plug the numbers into the correct location, same formula. Solving for a again, 14,000 times 1 plus r, 0.08, divided by 2 this time, raised to the 2 times 12. All right, so 2 times 12 is going to be 24, so our exponent's 24 now. All right, so it should be a little bit more than the other one. The more times they add money into your account each year, the bigger it will grow, okay? So 35,886.26. That's a little bit better. All right, option 3, quarterly. So now n is 4. Think of 4 quarters in a dollar. So 14,000 times 1 plus r, 0.08, divided by 4, raised to 4 times 12. So now we're raising it to the 48th power. All right, so it should be a little bit better. So 36,218.99. All right, so right now option 3 looks like it's the best. All right, now option 4, continuously. All right, so continuously means it's just going to add interest into your bank account like this every second. It's adding money into your account, okay? It's just pennies usually, but you know, when you're doing this for a year, it adds up. All right, so we're using the PERT formula. So A again is what we're solving for. P is our 14,000 times E raised to the interest rate, which is 0.08 again, 0.08 times 12 years. Right? So again, you got to practice using your calculator, especially on this kind of problem. Some of your calculators, you just type it in this way. Make sure this 0.08 times 12 is up in the exponent. Some of your calculators, if you don't put parentheses maybe around the 0.08 times 12, it's going to drop the 12 down and multiply it times 12 instead of raising it to the 12th power. So it's up to you. What was that? Question? All right. So make sure you find your E button, E to the X. So 0.08 times 12. Yeah, find your LN button, and it's the E to the X is right there. All right, so you should get 36,563.75. All right, so out of all four of options, looks like option 4 is going to give us the best profit. All right, number 5. Ryan deposited $1,200 in an account that pays 5% annual interest compounded monthly. Okay, so there's that compound interest. How much money will he have after 6 years? All right, so let's identify what each of these numbers mean for the formula. So we're depositing $1,200, that's P. 5%, that's our R. As a decimal, 0.05. Monthly means N is 12 months in a year. We're looking to find how much money is in the account. That's T. We don't know what that is. And wait, sorry. We don't know what that is. That's A. A. How much money is in the account? That's our ending amount. After 6 years, that's T. There we go. So let's plug all those numbers into our formula. All right, we don't know what A is, so that's what we're looking for. So 1,200 times 1 plus 0.05 divided by 12 raised to the 12 times 6. All right, so again, that exponent, 12 times 6, that's going to turn to 72. Okay. All right, so it looks like 1,618.82. So we start with $1,200, and after 6 years, should have $1,600. All right, number 6. Given an investment of $5,000 of an account paying 3% annual interest compounded quarterly, so compound interest again. How long will the investment have to be? How long will the investment have to be to make $7,000? Okay. So let's identify what each of these numbers represent. So we have an investment of $5,000, so that's going to be P. 3%, so R is 0.03. Quarterly means that N equals 4. See, we want to end at $7,000, so that's A. And how long it's going to take is T. We don't know how many years. So this one we're going to be solving for T. All right, so let's plug all the numbers into our formula. So 7,000 equals 5,000 times 1 plus R, which is 0.03 divided by 4 raised to the 4 times T. So again, because our variable's up in the exponent, okay, we're going to be using logs. Okay, again, the steps are exactly the same as I think it was question number 3 on the other side. Steps 1, divide by 5,000. Step 2, on this kind of problem, I would simplify this down to a decimal. Okay, to turn this into one single number rather than all this stuff here. Okay, because that's our base. So divide by 5,000, convert this into just a decimal, and change it to a log. Change it to log form. Then you can use the change of base. Okay, so we're going to divide by 5,000. So I'll just simplify this down. Let's see. Okay, this does stop at 1.4, so it's just easier to put in 1.4. All right, so then 0.03 divided by 4 plus 1 is 1.0075 to the 4t power. All right. Now we're going to change it to a log. So 1.0075 is our base. Okay, that's the subscript. Put that subscript. Flip here. All right, so log with the base 1.0075 of 1.4 equals 4t. Now we can do the change of base, or if you can do the subscript in your calculator, it's going to be up to you now how much more you have to write. All right, now this is equal to 4t, so then we're going to have to divide both sides by 4. So we're going to divide this whole thing by 4 then. So in your calculators, most of you anyway, do log 1.4 divided by log 1.075, put the equal sign, divide that answer by 4. All right, we're going to 3 decimal places on this, so it looks like 11.258. That's years. All right, let's do this last one. Ariel deposited $625 in an account that pays 4% annual interest compounded continuously. Okay, so we're using that PERT formula. How long will she have to invest to double her money? Okay. So let's identify what each of these numbers represent. Deposited 625, so this is P. 4%, R is 0.04. Continuously, that just means that this is the formula we're using. How long it's going to take, that's T. We don't know that. And we want to double our money. Now, we can figure out what the doubled money would be. So what would the ending amount have to be? 1250, right. Okay? Just take the starting amount, 625, and multiply by 2 to double it. So we want to end, this is our ending amount, A. All right? So now we'll plug all those numbers into our formula and solve for T. All right, so 1250 equals 625 times E raised to the 0.04 T. Again, the steps are similar to this one right here because our exponent is the variable. So first step, divide, change it to a log. Right, so divide by 625. So that's 2. Change it to a log. So log, our base is E. 2 equals 0.04t. All right, so log base E2. We're going to change that because E is a special base. That's the same as ln 2. Hopefully you guys did that on the quiz, because I think there was a problem on the quiz like that. Okay. Now we're going to divide both sides by 0.04. Okay, you're not dividing 2 by 0.04, you're dividing ln 2. So be careful on the calculator. Get that decimal ln 2. Okay, and then divide it by 0.04. All right, and then we're going to 3 decimal places again. So this is 17.329 years.